All right, so here's the last example that I'm going to do. I'm going to do extra things so that I can go through some things since I'm not there with you. All right, so f prime, I'm going to do that first since I know I need it to find critical points. So f prime, I'm going to use the quotient rule. However, I see that I could divide that x squared through and think of this as an x squared plus 1 over x squared. So if you want to take the derivative that way, it is actually much faster. So I just know that finding values of the derivative is easier this way, and so I'm going to do it that way. All right, low d high. I've already messed up my d high. D high is 4x to the third. I was trying to put my 3 in the wrong spot. Minus high d low. D low is 2x all over x to the fourth because 2x squared. All right, so I'm going to simplify that a little bit because that looks icky. So this is not a negative number right here, just so we're all clear. That is a positive 4. It was a stray mark there. Okay, so I have 4x to the fifth, and that's 4x to the fifth, and I know I'm going to have a minus 2x to the fifth, so 4x to the fifth minus a 2x to the fifth is a 2x to the fifth. I'm combining like terms at the same time, so if you want to write out your distribution, that is fine. Minus 2x, I know that I have a minus 2x because minus 1, because this is a negative 1 times 2x is going to be minus 2x. All right, x to the fourth. I see that I have a common factor on top that I'm going to cancel out. So I'm going to cancel out 1x. I'm going to take out an x from all this. I'm going to factor it out. All right, so that'd be an x to the fourth when I factor it out. And so I can cancel that x and make that an x to the third. So my 2x to the fourth minus 2 over x to the third is going to be my derivative. All right, so endpoints. There are none. In that they go to infinity, it goes to infinity and negative infinity without bound. If we think about horizontal asymptotes, as I go to infinity, I'm going to go toward x squared, so I'm going to go to infinity, and then I'm going to go to positive infinity again as I think about my horizontal asymptote. So I know that I'm going to infinity and going to negative infinity at the endpoints. As I think about limits as I go to infinity and negative infinity. I also have one problem with my domain, right? I cannot have x equals 0, so that's in some ways kind of like an endpoint. X equals 0 is not in the domain, so I'm going to put that there because it is a vertical asymptote. So I'm going to put that vertical asymptote kind of on my sign chart. All right, now, where is f prime equal to 0? Well, remember what we talked about in the last example. That only means the top of f prime has to be equal to 0. So I'm going to put 2x to the fourth minus 2 equal to 0. So I get 2x to the fourth equals 2. So I get x to the fourth equals 1. So x equals plus or minus 1. So I have negative 1 and positive 1 as critical points on my sign chart. Third thing we have to check is where f prime does not exist. Well, f prime does not exist if there's a problem in the domain of f prime, and so where x cubed equals 0. Well, where does that happen? Where x equals 0. So now I have 3 critical points, and my vertical asymptote showed up there, right? Because there's no derivative where there's a discontinuity in the graph. So I really didn't need to consider this here because it's not really an endpoint. But I did just kind of to talk about domain. Now I graphed at this, and I know it looks kind of like this. All right, so I kind of know in advance what I'm looking for, but we're going to do it and prove it algebraically, prove our extreme algebraically. All right, so I'm going to put in negative 2 this time to my derivative. My derivative I've made look very messy here. So I'm going to put in negative 2 to the top. I get 2 times negative 2 to the fourth. That is going to be a positive number. Anything to the fourth power is positive. Minus 2. Okay, I got a positive number on the top. If you want to actually go ahead and plug negative 2 in all the way, go for it. So positive on the top, and the bottom is negative 2 cubed, so it's negative on the bottom. Overall, my f prime is negative. I am going to put my arrow on this end because I forgot to do that. On this part of the function, I'm going to put in like negative 0.5. Well, negative 0.5 to the fourth power. That's positive 1/16. So I have 2 times positive 1/16. That's an eighth. So I have an eighth minus 2. That's negative on top. If you want to go ahead and substitute your negative 0.5 in all the way and double check that, you're welcome to do it. But it's negative on top. Negative on bottom because any negative number cubed is negative. So overall, I have a positive derivative there. So I now know that I am decreasing my function. My f is decreasing, and then my f is increasing. All right, I'm sure that it's decreasing again looking at my graph. And almost always they flip signs, but not always. That does not always happen that it goes plus minus or minus plus minus plus. All right, so, and that's because there could be an inflection point. All right, so we're going to plug in positive 0.5. Well, if I put in positive 0.5, I get the 1/16 again, so I've got 1/8 minus 2, that's negative on top, negative 7/8. And on the bottom I have a positive cubed, so I'm going to get a positive number. So overall, negative divided by a positive, it's negative. My f prime is negative. My function, my f, is decreasing. All right, if I put in 2, I'm going to get 2 times 2 to the fourth. That's 32 minus 2, that's 30. That's a positive number over positive number cubed. That's a positive number. So my slope is positive, so my function must be increasing. All right, so we can see by looking that these guys are going to be relative mins, both of them, all right, because we switch from decreasing to increasing. So I'm not going to talk about increasing and decreasing this time to save some space, but if you really want to, we can say, I'm going to just say it out loud. So f is decreasing from negative infinity to negative 1 and 0 to 1 because f prime is negative, or the slope is negative, and f is increasing from negative 1 to 0 and 1 to infinity because f prime is positive. The slope is positive. The derivative is positive. All right, so let's talk about extrema. All right, so f has a relative min at x equals negative 1 and 1 because f changes from increasing, try again, Miss Kite, decreasing to increasing. You could have also said because f prime switches from negative to positive, or the slope changes from negative to positive, same thing. All right, so it has a relative min there. Now, it looks like it has a relative max right here, but wait, remember that's a vertical asymptote. It's actually not. It's an infinite discontinuity. So don't make that mistake. Now, you can, if you say that, and you really do go back and double check your answers, because I'm going to do that. I'm going to do f of plus or minus 1 and check my critical points. And I found out those both have a value of 0. And when I plugged in my critical point f of 0, I found out that, and I'm sorry, it is not 0. Let's try that again. I plugged that into my derivative. Don't make the mistake. That is a very easy mistake to make. So plug it back into your original. So if I put in 1, I get 1 to the fourth plus 1 all over 1 squared. So I get 2 over 1. I get 2. And if I put in negative value, those are going to be positive because of the even power, so it will also be 2. So either way. Now if I put in 0, I get 1 over 0, which is undefined, and so we would be reminding ourselves that it is a vertical asymptote. So if you accidentally make the mistake, you should always double check these to find your global mins and maxes. By the way, that is our global min. Okay, that's our global min, which you find by thinking through logic. We know that it's starting at negative infinity because we talked about limits when we started, and we know that it has a min, and then it starts increasing again to an asymptote. And then we start up, and we could figure out we know we start up, but we could figure out using limits that we start at positive infinity up there. But we know we're coming down that whole way, so it has to be that we're coming from infinity down to a min, a relative min. We proved that it was a min. and then starting back up again. So you can also use that as kind of a way to know your end behavior as well. If I'm coming down and going up. Now, I guess you could be leveling off to a horizontal asymptote, I guess, out here. So you should check your limits still to make sure that end behavior. But there we go. So this is actually a global max, which we kind of just logicked out going, all right, it's coming down, it's touching, it's going up. And since those are at the same level, they have to be both a global max. So there we have it. We have relative. I said max. Darn me. Anyway, it's a min. I like to use the wrong word a lot, so you're going to have to fix me a lot. It's a global min, global min, global min. So we have a relative min that is, in fact, the global min, and it occurs in two places. And we also kind of have a sketch of a graph that looks very much like our original. All right, so that's the end of our examples. We'll talk more in class if you have more questions.